Hello everyone. Today I want to explain about the second part of a multiple regression. So last session we saw that how we can use the stepwise to run the multiple regression. So multiple regression has many factors as an independent variable and then one dependent variable. So we chose the depression as a dependent variable, and then the factors was the emotional balance and the economic resources and physical health. And then finally, the result was only emotional balance, explained the variances about the depression, and the other variables like physical health and economic resources were excluded. So to examine the linearity and also the multicollinearity, today I want to choose the another factors. So depression can be explained by the emotional balance, but this time I can choose that um, there is self-esteem. So this one is a self-esteem. And then also I want to choose that social support. Okay, so let's try the factors as a self-esteem and social support, emotional balance, how they affect the depression, and that depression can be explained. So this is our task for multiple regression today. So about the assumptions, the depression, there is a dependent variable should be normally distributed, and another assumption is that the linearity. So this means that the dependent variable, there is a criterion variable that should be related to I mean, they should be a linear relationship with the factors. So today we can check that first. So analyze and then correlation and then favorite. And then you can put here the all variables you want to use. That is depression, and then self-esteem, social support, and then what was emotional balance. Okay. So let's see how they are related. So, okay. And in the correlation matrix was generated. So you can see here only the one thing, depression, how they are related in the other factors as a linear relationship. So significance is 0.02, so it is significant. And the social support is not significant because 0.8 means depression and the social support are not related. And then emotional balance, yes, that is significant. So from this matrix table, you know already social support cannot be a factor because there is no linear relationship. So you will exclude this. We will use the only self-esteem and the emotional balance. Okay, so we can run the multiple regression with the two factors. So analyze, and then you will go to the regression and then linear, and then depression, and then here you will erase that, and then this one also, that was from the last part. So this time you will put that emotional balance and then the self-esteem. Okay, and we still use the stepwise because that means the unsignificant variables will be automatically removed. So we will choose that, and the statistics you will estimate, and then model fit R square change. So R square change you need to check because they are more than two factors. So you want to see how R square changes. And the collinearity diagnostic. So this is what we are interested in this analysis. Continue. The plot is the same like a residual y and the predicted x. And then we want to also check the normality of residuals, so you can generate that. And then in the save option, unstandardized, and we want to know predicted intervals of an individual. That is a confidence interval 95%. So we will know each individual, how is the range of the lower and the higher value with the 95 confidence interval. So that is okay. And the options, that is a default. So that is okay. So this generates the multiple regression output. So you can see the stepwise is used, and then by stepwise, the machine chose the factors, emotional balance and the self-esteem, both of them. They explain the variances about depression. So here you can see that the A is only one emotional balance was entered first because this is higher than the other. So the emotional balance is the most strong factor about the depression. And the second model, you can see model two is a predictor, is the emotional balance and the self-esteem. Now self-esteem also added. So in this model summary, you can find that R square increased. So when you use the model two with the two factors, the model, R square increased. This means that you can explain about 29%, almost 30%, with two factors about the depression as a cause. So here you can see this is the summary of the two factors and how they explain this depression. And you can see here R square changes. So the first one is the only emotional balance that is 26.8%. But with the self-esteem, it's not much, but about 2.5% is added. So finally, that becomes 29.3%. And also the F change is significant. So we took these two factors with the emotional balance and the self-esteem as ANOVA table also shows that it is significant. So we will take the model 2 because that increased the R square. So we will have the model 2. You don't have to report the model 1. There is only one variable. So this one model 2 is of two factors. So you will report the F value and the significance, and also the other information about ANOVA table is about the model 2. And in the coefficient also model 2, still we see that. And when you write the that equation, you can take this constant. So 51.2324 plus, and now you say minus 1.0, and then you will write in the parentheses about emotional balance and plus minus 0.26, and then your the parentheses, and then you put the self-esteem. So in fact, this is the sorry, the mother two only that is the information to write your equation of the regression equation. So here also you have the beta. So that is about the emotional balance and the self-esteem. That is the R value. So we have here that one, but in fact that is a mixed with the two things. So it's not exactly the same. But you can see that from where it's coming from the emotional balance is greater than the self-esteem. So here now multicollinearity, you can check that. Normally that should be the greater than 0.1, and you can see the 0.9. So emotional balance and self-esteem are not at all very close. This means that they are not, they don't have the multicollinearity problem. So you can check with the tolerance here. Remember that it should be the greater than 0.1, and this is very much greater than 0.1. Okay, and then yeah, so this is about all things that you used to check about the multicollinearity from here. And then you have another table to report the model 2 as information. And then here the model 2 again, that is about the right to your regression equation. And the model summary that shows the how much variances you can explain. This model can explain about the depression that is almost 30%. Okay, so this is about the second part of the multiple regression, and you saw that how you can interpret the multicollinearity from this section. Thank you.